Because we went over this quickly in class, I just wanted to take a little bit more time to go over this last balancing problem. So I'm just going to take my atom inventory and fill out this chart. On the reactant side, we have 2 carbons, 6 hydrogens, 2 oxygens. On the product side, we have 1 carbon, 2 hydrogens. Now we have 3 oxygens. We have 2 here plus this 1. So it doesn't really matter where you start, though I wouldn't start with your oxygens. I would start either with getting your carbons to match or your hydrogens. So if I put a 2 in front of CO2, that's going to change my carbons to 2, and then 2 times 2 is 4 oxygens plus the 1 oxygen from here. So that's a total of 5 oxygens. Then if I look at my hydrogens, I have 6 and 2. So if I put a 3 here, 3 times 2 gives me 6 hydrogens. 3 times 1 gives me 3 oxygens plus the 4 from over here, so that's a 7. Okay? The good news is my carbons and my hydrogens match. The really bad news is I can't turn a 2 into a 7 using a whole number. Okay? I can turn a 2 into a 7 using a 3.5, which you know is an illegal move. You can't have decimals or fractions. You have to have whole number coefficients. But the trick to this is to multiply everything by 2, okay? So instead of having a 3.5 here, we would put a 7. Instead of having a 2 here, we'd put a 4. Instead of a 3, we'd put a 6, because we're multiplying everything by 2. And then instead of a 1 here, we would put a 2, okay? Now I'll go back in green and just double check this. So if I look at my carbons, I have 2 times 2 is 4. My hydrogens, I have 2 times 6 is 12. And then my oxygens, I have 7 times 2 is 14. Over here, 4 times 1 is 4 carbons. I'll just do my hydrogens next. 6 times 2 is 12. Okay, and now let's do my oxygens. 4 times 2 is 8 oxygens plus 6 times 1 is 6, and that is 14. So if you look at my green numbers, 4 and 4, 12 and 12, 14 and 14, everything is good. So the coefficients here, don't let that confuse you, is they are 2, 7, 4, and 6.